Okay, we're looking at a modeling parametric equation question from the textbook, 8.5 Edexcel, I think it's example 13. So we have the motion of a figure skater relative to a fixed origin O. At time t minutes, it's modeled using the parametric equations x equals 8 cos 20t, y equals 20 sine brackets 10t minus pi over 3, where time, in this case, for an ice skater, is greater than or equal to 0. So question A. We want to find out, x and y measured in meters. So we want to find the coordinates of where the figure skater begins their motion. Well, naturally, they're going to begin their motion when t equals 0 seconds. So x equals 8 cos 20 times 0, which is 0. So x equals 8 times 1, so that's 8. And y equals 12 sine, and we've got 10 times 0, and then so that's 0 minus pi over 3. And I'll get my calculator off screen. Sine minus pi over 3 times that by 12, and I've got minus 6 root 3. Okay, so the figure skater starts at the following point. So that's question A done. Lovely. Okay. Question part B. Find the coordinates of the point where the figure skater intersects its own path. So I can see that here. So it's going to intersect its own path when y equals 0. Okay. So we're looking at the equation. 0 equals 12 sine 10t minus pi over 3. So what we can say here is, if I was to get my sine graph, we have the following. So we want sine the following to sort of represent 0. So what we can say here is so we need 10t minus pi over 3. Firstly, that can equal 0, which is fine. 10t can equal pi over 3. So t can equal pi over 30. That would be our first option for when it equals 0. We can also have it, we can also get a second answer. So 10t minus pi over 3. It's in radians, so we wanted to equal pi in this case. So 10t can equal 4 pi over 3. We're doing pi plus 1/3 pi. So t equals 4 pi over 30, and that simplifies down to 2 pi over 15. That's fine. So we've got time so far for part B. Time can equal pi over 30, 2 pi over 15. If I let it equal 2 pi, we'd do the same thing, and we would eventually get 7 pi over 30, and this would carry on and on as we kept going with the sine graph. So we've got multiple answers there. So we want to find the point. I think any of these values will be acceptable, so we want it to, because we're going to keep going round and round when we ice skate. So we'll pick any of these. So what is the y, what's the x coordinate going to be? So we can say that x equals 8 times cos, and we're doing 20 times pi over 30. That will simplify to 2/3. And we're going to get x equals, let's have a look at it, cos of 2/3 pi. That gets me minus 0.5, times that by 8. So x equals minus 4. So that's our coordinate there. Lovely. Okay, that's part A. Part B. Let's duplicate this page now, and let's look at part C and D. So I will just erase that now. Okay, so part C. Find the coordinates of the points where the path of the figure skater crosses the y-axis. So we're looking for these following points here, here, and here. So we can say here that x will equal 0. Okay, so 8 cos 20t equals 0, cos 20t equals 0. So when we sort of come to draw our graph for cos, we want to get at least the first 4 in here. So we're looking here, 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 and here. So we want 20t. We want it to represent. Let's have a look. So we want it to represent pi over 2. We want it to represent 3 pi over 2. Let's have a look, 3 pi over 2. We want it to also represent, what am I adding every time? I'm adding, so 5 pi over 2. I'll just double check that in my head. Yep. And we want 7 pi over 2 as well. So that'll be our first sort of 4 attempts at that. Yeah, so we could sort of solve for t. So I could, if I wanted to, divide this by 20, but it doesn't matter because I'm just going to times it back up again and put it into here. So that's fine for that there. So moving on with the question. So we've got what 20t is going to equal. All we need to do now is we're going to substitute this back into the y value. So let's have a look at it. For the first one, y equals 12 sine. Now 10t is half of that, so I can say pi over 4 minus pi over 3. So when I get my calculator off screen, let's have a look at it. Pi over 4 minus pi over 3. We want to do sine of the following. And then times that by 12. And on off screen, I've got we'll go 2 decimal places, minus 3.11. For the other ones, I've got them pre-done. So I'll put them underneath so we can see 3.11. And then I've got 11.59. And then I've got 3.11. And then I've got negative 11.59. So there are my points there. We can just say 0 minus 3.11, 0, 11.59, 0, 3.11, and lastly 0 minus 11.59. So there we are, those are my points. Okay, last question. I'll make this a bit smaller now. I'll resize that. Okay, part D. Okay, for part D, we want to determine how long it takes for the figure skater to complete one figure of 8 motion. Well, what we can see for the x point, let's pretend we started here. What we can say here is, well, x equals 8 cos 20t. So if I was to draw, for example, if that was cos of t, for cos of 20t, we would sort of be multiplying it by a scale factor of 1 over 20. So what we can sort of say here is it would sort of be going periodically 1/20th faster. But to go back to our original position, or to do a full loop, we actually have to go around this essentially twice. We have to come back to the x, our starting position, a factor of 2. So in this case, if we're going round periodically, in a case of sort of 2 pi over 20. So what that means is if I had my cos graph again, to go back to my starting point, it would become, so if it was cos t, it would be every 2 pi, but in this case it's every 2 pi over 20. But we have to do this twice to come back to the original starting point, because if I skated round once, we're already halfway there, so we have to do it twice. So we need to times this by a factor of 2. So that means we're going to go around pi over 10 times 2, so every 2 pi over 10, and that'd be in terms of minutes there. So 2 pi over 10 minutes on my calculator, 2 pi over 10, that is every 0.628 minutes, times that number by 60, so 37.7 seconds, or I can say 38 seconds. Oops, spelled that wrong. Seconds to 2, so now we can figure. So there we are. Every 38 seconds we'll be doing one loop of 8 motion.